Hi, in this video, we're going to talk about compound inequality intersections, and we're going to talk about solutions that have special cases. So what we're assuming is that we've already either separated or solved the compound inequalities together, however you choose to solve your compound inequality, but these are the solutions that we ended up with, okay? So we're not going to go through more compound inequality solutions because I talked about how to get the solution in the last video and how to solve them. So we're assuming that, okay, we got to the point, we found the solution, and this is what we got. Okay, so let's look at what happens in example 1. So in the first example, we end up with x is greater than 2 and x is less than negative 1. Okay, so let's put this on the graph. And so I have, let's start at 0, 1, 2, and over here I have negative 1, negative 2, and maybe over here I have 3 also. Okay, so I'm going to graph these in different colors. So for the first one, x is greater than 2. Okay, so 2, obviously my 2 is not included in my solution set. So, and all the numbers are bigger than 2, so it points to the right. And then I end up with x is less than negative 1. And so negative 1 is also not included in my solution set, and I wanted to do that one in a different color. So let's try green. Okay, and this one points to the left because it's saying that all the numbers are smaller. But remember that an intersection contains the word and, okay, this key word here, and, so it means that these two graphs should actually overlap. So I'm looking for places where both inequalities are true at the same time, so they share common solutions. Well, when I look at this graph, that doesn't seem to happen. It looks like for one inequality, the solutions are going to the right, they're all bigger than 2. For the other one, they're going to the left, they're all less than negative 1. And so in that case, for this solution set, there is no place where the two different inequalities actually share solutions. So this is what we call a no solution. Okay, and it's okay when you get this, don't just assume that because you graph it this way that your graph is actually correct, but go back and make sure that you solved everything correctly and do some checks based on what you got for these inequalities here. And if you find that that's the case, that you have no solutions, and of course that would mean no solution. So what does that mean? Well, remember that the graphs have to overlap, so you're looking for places where the graphs share solutions, and in this case only one inequality is true, right? Remember that both have to be true, so this section is false. This section is false because no inequalities are true. And this section is false, again, because only one inequality is true. So there's no place where both inequalities are satisfied at the same time. Okay, so that is a no solution would actually be your answer, even though you actually got two solutions. Okay, let's look at another special case. So in number 2, I have, looks like, so we'll start at 0, 1, 2, 3, 4, 5. So it looks like I'm starting at x is greater than or equal to 3. Okay, so greater than or equal to 3, this 3 is included, and it looks like it points to the right. Okay, and then and also x is greater than or equal to 3 in the second inequality, so it's also enclosed, and it also points to the right. Well, in this case, my solutions are just x is greater than or equal to 3. I only need to write that once because it satisfies, both of these inequalities are satisfied when x is greater than or equal to 3. So 3 is included in my solution, so from here on, my inequality is true, but anywhere else, it's false, okay? So my inequality is true from x is greater than or equal to 3, okay? So when you see that, you don't need to write a compound. You certainly don't write it like this. 3 is less than or equal to x, which is less than or equal to 3. That doesn't make sense. It's just that x is greater than or equal to 3 for both inequalities. Okay, so then let's look at the next one. So number 3. Okay, so I have x is greater than 5 and x is less than 5. So let's look at this one. Let's graph this special case. Okay, so I have maybe 2, 3, 4, 5, 6, 7. Okay, so for this one, I'm going to graph x is greater than or equal to 5 first. So include it, greater than or equal to 5. This one points in this direction. The next one, x is less than 5. 5 is not included in the second inequality, and it points to the left because I'm looking at the values left. Well, we're looking at places where both inequalities are true. Okay, well, let's discuss that. In the first region, only one inequality is true at one time, so that makes this one false. And because it also has the word and, let's look at 5. Well, 5 is true for the first inequality, it's included, but for the second one it's not, so it's still false at 5. And then let's go to the right of it, and we still only have one inequality true, and so the inequality is still false because both inequalities are not satisfied by our solutions. Okay, so that makes this one, again, a no solution. Okay, so no solution for this one. All right, so now let's look at number 4. Okay, so what happens when we get something like number 4? Let's graph it first. Okay, so what I have is, it looks like -6. So maybe over here, -5 and -7. Okay, and this time I counted correctly. Okay, so let's graph both of these. So I'm going to start at -6. -6 is included in this inequality, and it wants all the solutions that are less than, which are the solutions to the left. And then for the second inequality, -6 is also included, and it wants all the solutions that are greater than, which point to the right. Well, let's evaluate this one. Okay, so we remember that it's and also, so it's an intersection, so we have to satisfy both inequalities. And on this case, only one is satisfied, so this part is false. And when we look to the right, only one is satisfied, so this side is false. But what about when we look at -6? Well, for -6, both inequalities are satisfied, so only at this point, -6, are both inequalities satisfied. That's the only point that they share. And so in this case, our solution really becomes x is equal to -6. Okay, so that's a special case because it's only equal to that one value of -6, not -6.1, not -5.999. It's just -6. That's the only thing that satisfies both inequalities. Okay, so these are all special cases, and so when you see these, just know that something is going on with your inequality that is causing it to be a special case. Okay. Alrighty, I hope this has helped, and I hope this helps you as you continue to get your solutions and to be able to interpret and read the graphs of your inequalities. See you in the next video.